Thank you, Dr. Radhika. That was pretty insightful. So now that we have done a pretty decent job of getting the inventory into Target and optimizing it, when shoppers come in, we need to make that journey personal. And that's the topic for today. It's about our personalization journey at Target. Well, in some ways, it's a story about all of us. It's about how we like our shopping experience to be. And as a technologist, it's about the science, engineering, and data of how we design systems that measure personalization. From a shopper standpoint, personalization comes down to a few things. It's about your preferences, it's about your needs, and it's about your behaviors. And at Target, we believe that every shopping journey is unique, and we strive to make that journey uniquely yours. For quite a while, it's been pretty clear to the retail industry that the one-size-fits-all approach does not work for shopping. Every shopper is unique. And on the screen, you will see studies by two very prominent organizations which talks not just about how important personalization is, but also about shoppers saying that if they get an impersonal experience, they might not even come back to a retail site. So you see studies by Adobe and McKinsey, and it's a very, very similar result. But we also need to understand that organizations and markets are at different levels of maturity when it comes to personalization. As someone, or like many of you in the audience who grew up in India from 80s to early 2000s, you would remember that something like grocery shopping was hyper-personalized. You would go to the corner Kirana store, and the person who ran it knew exactly what your family needed. They would know your likes and dislikes, and they would very often even take decisions on your behalf to see what brands to introduce to you and what not. A hyper-personalized model, but not scalable. Move on to the US market, where organized retail has been there for quite a while. There is a lot more data and data available on what shoppers like and dislike. Consider Target. We're a large box retailer. We run close to 2,000 stores. We have a pretty busy .com site, but we also have a big loyalty program. There are also multiple interactions that guests have with our team members, either via our call centers or maybe even when they walk into a store and talk to somebody. And all of these are touch points of data and footprint that they leave behind. Looked at individually, they look something like this. But with 8 out of 10 US shoppers being Target customers, it takes quite a bit of effort to connect all that together and get the complete picture. And that is what we try and do at Target, to make sense of the data and personalize your next shopping experience. Today, we're not going to talk about the why of personalization more. We're going to talk about how we do it at Target. We'll look at a couple of examples and see how we build those systems, engineer, and scale it for our use cases there. The first one out there is about how we make recommendations on what to buy at Target, and we call it as Buy It Again. And then we'll talk about a use case where we look at not just historical data or your past purchases, but also try to layer in your recent patterns, like your browse patterns, to see how to make sense of data much, much closer to real time to drive your experience out there. And to start with the Buy It Again use case, I'll invite Melissa on stage.
Hi, everyone. Good morning. My name is Melissa Ludack, and I have the honor of leading Target's data sciences teams that build solutions within our digital and marketing portfolios. And as we talk about personalization today, we're going to start by talking about a batch use case, as Hari mentioned, specifically Buy It Again. Now, Buy It Again recommendations are a crucial tool for retailers as we try to improve user experience on our website and our app, as well as to drive and improve just the guest experience and in their interactions with us. And what you're seeing on screen behind me right now is examples of how those Buy It Again recommendations come to life across our digital platforms. And while many retailers have Buy It Again algorithms that generate similar recommendations, the approach that we take at Target is a little bit unique. Now, Buy It Again can be formulated as a session-based recommendation problem. Our goal, given an ordered list of purchases that a guest has made, is to be able to predict their next purchase. In other words, we're really trying to identify those things that they're going to run out of before they run out of it. That way, they can add it to their shopping list and hopefully buy it at Target. Now, existing works formulate this as a sequential recommendation problem. And traditional sequential recommenders are often used, such as sequence pattern mining, Markov chains, and deep learning-based sequential recommenders. However, repurchase is not a single session event. It happens after a few days and often after a guest has interacted with us multiple times. And there are a plethora of papers that discuss all of these approaches, focused on finding that repurchase probability for each item that a guest has purchased. And most of these solutions seek to then rank the items according to the decreasing probability of repurchase. And we've tested these models and our own on 4 open data sets and identified which one would be the best. And we have found that our data set, or our model, performs the best by 16% on NDCG and 4% on recall. We've also learned that many of the other solutions that have been created and are used today do not scale well with the size of our data set. So how we build is we start by taking a look at guest behavior. Repurchases can happen from a few days to a few weeks to a few months because consumption rates vary. Bananas versus cleaning supplies is a perfect example of where we see this. Bananas have a high likelihood of being repurchased once every 7 days, whereas cleaning supplies have a repurchase cycle much closer to 21 days. We also know that our guests shop differently on a weekday, maybe it's a Wednesday and they forgot something that's crucial for dinner, versus on a weekend when they're buying everything that they need for that week. We also discovered that our guests are more likely to repurchase within a category versus an individual specific item. Yogurt is a perfect example of where we see that. Our guests typically will purchase yogurt every week when they're making that big stock-up trip, but they will purchase a different brand, different size, different flavors, sometimes even opt for the one on sale that week. And it's because of this behavior that we have seen across multiple categories that our modeling approach actually starts at the category level. So we begin by using omni-channel sales data for our digital guests. This means that we use their online and offline sales information. For offline sales information, we take identified guests and we look at their behavior within the stores, and we can identify them because they're a member of our loyalty program, as Hari spoke about, or they're using a tender that's actually saved within their digital profile. We use 1.5 years of sales information, which allows us to be able to capture seasonality impacts in our recommendations. So our main modeling approach consists then of 3 stages. The first is that we want to generate a list of ranked categories that our guest is most likely to be running out of. To rank our categories, we use an ensemble of ARIMA models, survival analysis, and other features in a 2-layer, fully connected network. Our ARIMA time series models look to model the consumption rate as well as the inter-trip times for our guests. Survival analysis is all about predicting the probability of repurchase after end days. And the other features that I mentioned include the number of times that a customer has purchased from the category that we're modeling, the number of purchases in other categories that they've made since they purchased in our current category, and the time difference between today and the last date that they purchased in the category that we're modeling. In stage 2, we seek to understand and rank items within those categories. And to do this, we use recency and frequency-based regression models. And then in our third stage, we combine those ranked categories with those ranked items. We take the first item from each category, the second item from each category, and so on. This entire modeling process runs in Apache Spark on our Hadoop cluster, which we call Big Red. And the modeling process takes less than 8 hours, while also leveraging 8 terabytes of cluster memory. The recommendations are then exported to Cassandra and ultimately served to our guests. And we've seen that these buy it again recommendations save our guests time building their carts, but also help to drive sales for Target. For our guests that use same-day delivery, we see a 5 to 7% increase in order value, along with a double-digit increase in the number of units per order. We also see improvement in the time it takes our guests to build their shopping carts because they don't have to go to as many pages to build those carts. And we often see that our guests are interacting with these recommendations, nearly 20% on our app home screen, or 7% across all platforms. And to help put that into context, when it comes to recommendation carousels, we typically see interactions rates much closer to 5%. And while Buy It Again is a batch use case, I'm going to bring Harry back on stage so he can talk a little bit about real time.
Thanks, Melissa. Buy It Again is indeed a great use of how longitudinal signals or your past purchase, what you bought when, indicate your preferences. But while past purchases are important and they're extremely important, sometimes they're not enough. And we'll talk about another example where you need to layer in near real-time data onto past purchases. And that's going to be about contextualizing search, about how you contextualize your search experience at Target. Okay, I'll start with an example. Let's say you're on Target.com and you type in the keyword called shoes. If my past purchase history has to go by, my ideal top 10 results would look like men's shoes, right? That's probably, or maybe some kids' shoes. That's what probably I buy at Target. But today, let's say I'm a reformed person and probably want to buy a gift for my wife to make up for something. So my context in this very instance changes, right? I'm no longer looking for men's shoes, but at this very instance, I would like to purchase women's shoes. But my keyword still remains the shoes one. Or let's take another example where someone's trying to buy a dress at Target. Their past purchases might indicate a preference or an affinity to a particular brand, a size, and we generally curate their search results to say that, okay, hey, this is a size that you bought in the past, and this is what you would like. But what if it's a category which you've never shopped at Target? Or if it's a new brand which you have not bought? So these different touch points, before your browse patterns in these different touch points give us some data to kind of tell you, and which helps us understand your context. And we try and use that context to personalize your search experience even a little bit more. Why is this important? From a shopper standpoint or from a guest standpoint, it allows them to save time. Understanding that their interest and intent makes their search faster. And most importantly, it allows us to deliver a personalized experience to the guest. Now, how do we get this data? We have things like past purchases, your store trips, but most importantly, we have clickstream data from your browse patterns. Now, this is data that's coming along as you have been navigating the site, right? And the architecture that you see here is what we use to take in the data, ingest it, curate it, decorate it, pass it on to inference model, derive the context, and then serve it using high-scale APIs out there. So the key here comes down to scale. Like on a regular day, somewhere at Target.com, you're generating close to billions of events. And on a day like Black Friday, the scale increases multifold. So this data pipeline needs to ingest, curate, and derive context at that rate, keep up with the pace at which what is happening out there. You see a tech stack that we have been using. We heavily rely on Kafka streams to kind of like transfer the data, understand the data. We've also been pretty much experimenting with the state store within Kafka stream to see how we can use that. In this particular example of contextualizing search, you see that we kind of derive the context and put it on in Cassandra and serve it using high-scale APIs out there. But remember, this pipeline needs to do the same thing over and over again at scale. And that's where the magic happens. Now, let's take a particular example within search called type ahead. So type ahead is nothing but you type in a keyword and then you get suggestions on what the next things are. You get that generally with any search engine or any search box. Now, in type ahead, the suggestions that come after you, what are we trying to do there? We are most likely trying to predict what you would engage with, right? Given a search term. So in this example, you will see a search term called as cat. Cat and Jack is a very popular kids clothing brand at Target, right? And I buy it always for my daughter. So when I type in cat, my most likely suggestions are going to be from Cat and Jack. But let's say I also happen to be a pet parent and I have a couple of cats at home. Today, in the very instant, the word cat means something very different to me. And while I was browsing Target.com in the past few minutes or seconds, I've given enough indicators to the system to say that, hey, my context for today is a little bit different. It could be through the query event, it could be through the category pages I browsed, or it could be even through some of the products that I added to my cart. So what we're doing in here is that we take all of these events, calculate feature scores on this event, create embeddings on it, and pass it on to the model. And this model has been trained on past events and embeddings as well. But realistically, you have because we need to stay very, very close to real time, you have a minimal set of data on which the model needs to take decisions. And hence, you will see the choice of Siemens network models there, framework there, which allows us to take these decisions quite fast. Now, say, with my patterns, suddenly the word cat has my derived context of not the clothing brand, but of pet supplies, and my suggestions should ideally change. So and you see some of the results here, right? So you see that now with the word cat, my type ahead suggestions have changed, and now in this case, the pendulum has swung too far, and it has kind of given out the popularity scores, and it is looking pretty much about only within that particular category. Depending upon different shopping patterns, the result could be different, would look different for each of us, right? But the key here is that the popularity score of my past purchases and the overall popularity score of the brand Cat and Jack gave way to the context of pet supplies. And how did we do that? When we calculated the feature scores that you saw in the past, we also associated a time decay with a heavy bias towards recency. And it is a recency bias that kind of shifts the pendulum on the other side here. And we spoke about optimization in the last talk, right? And optimization is key here. Optimization at all aspects, including the data pipeline that you saw there, where we get the data and feed it into the model. In fact, for those of you out there who might want to try it real time, it may not necessarily work because we discard any event that is generated outside the US geographic area, because it's a huge, huge data sets. We're talking about billions of events in a day. Now, this is one particular example of how context works. Context involves many, many things, right? It is not just about the categories. It's also about the brand, the fulfillment options, and a variety of different aspects out here. And that's what you see there. Once we started doing this, and we don't claim to have solved it all, right? We are in a journey in personalization, and these are some of the few things that we've been trying out. And we've started seeing very, very good results out here. And you see some of the results here. When you introduce a size, context, and facets, it kind of started, we got a lift of 1% on detail page views, and similar in other aspects as well. And for those of you who track e-commerce metrics, 1% increase in page views, detail page views, lead to subsequent articles and eventual conversion out there. So that was about our journey in contextualizing in search. But most importantly, when we try personalization at Target, and the talk wouldn't be complete unless we talk about our responsibility towards you, the guest out there. We do personalization at Target, keeping you, the guest, at the center of it all. And to complete this talk and to talk about our responsibility as an organization of using AI to personalize your journey, I'll invite Melissa back on stage. Thank you.
So, as Hari said, we have to talk about responsible AI when we talk about personalization. And at Target, we use 7 guiding principles, including transparency, explainability, accountability, security, safety, equity, and privacy. Equity means that we ensure principles of diversity, equity, and inclusion are appropriately accounted for in all of the AI solutions that we build. And when it comes to privacy, which is critical with guest data, we will develop and deploy AI that appropriately collects, uses, and shares personal data while complying with our privacy and information security policies. All AI practitioners need to not only develop principles around responsible AI, but make sure that they implement them when they're building their solutions. And today we've talked through a batch use case as well as a real-time use case for personalization. And we would not have had success with these if our engineers and our scientists didn't work in close partnership to deliver. And so what were the lessons learned? What worked well for us? First, our engineering, and our scientists' work out of a single backlog meant that our engineers and scientists were moving at the same speed, allowing our solutions to be deployed when they were ready. Second, being open to learning from one another. Our engineers can teach our scientists how to write more performant code, to think about the solutions that we're building as a total system. And our scientists can teach our engineers all about data, how to pull more insights out of their data, as well as different modeling techniques. 3, alignment to a common goal. I know you've heard it before, but joint OKRs are critical. They allow us to keep the guest at the center of everything that we do and ensure that everyone is working together towards the same business outcomes. And finally, personalization is an entire experience. It is not just a single model. We have to allow our models to interact with one another so we don't deliver competing insights and recommendations to our guests. The personalization story has to be one story about a guest told throughout their interactions and their entire journey with us. And there are many fun things and fun spaces ahead within the personalization world. We're excited about all of the new techniques that are coming online, the new technologies that are in front of us, and we have a great team of amazing scientists and engineers. It's exactly the fun world we love to live in. Thank you.